Okay, let's dive into this. Welcome to The Explainer. Today, we're unraveling a genuinely perplexing medical mystery. We're looking at the case of a 72-year-old man named James McKeefrey. And let me tell you, his clinical assessment reads way less like your standard medical file and a lot more like a forensic investigation into a collapsing power grid. It is a fascinating, step-by-step look at what actually happens when the human body's deeply interconnected systems start to fail. And spoiler alert, it doesn't happen all at once. It happens layer by layer.
So our story kicks off with a pretty alarming inciting incident. On January 13th, 2026, James suddenly passed out, and not just once, but multiple times within a single 24-hour window. But here's the critical detail you've got to keep in mind. He wasn't out running a marathon or under any kind of extreme physical stress. He literally lost consciousness during perfectly ordinary, mundane, everyday activities. We're talking about getting up for a middle-of-the-night bathroom visit or just standing up after taking a hot shower. The triggers were incredibly simple, just a change in physical position and heat. Obviously, he was rushed straight to the ER.
Now, what's really interesting about this slide is the massive disconnect between the ER's initial diagnosis and the hard evidence. The ER gave James a working diagnosis of seizures. They even went so far as to give him an IV dose of a pretty heavy anti-seizure medication. But, well, the data told a completely different story. Two separate EEGs, including a massive 72-hour ambulatory study, showed absolutely zero epileptiform discharges, meaning there were zero seizure brainwaves, none. On top of that, a 21-day cardiac event monitor completely ruled out any arrhythmic causes from his heart. Think about it. Seizures are usually triggered by things like sleep deprivation or flashing lights, right? Not by taking a warm shower or simply standing up. The actual medical data entirely contradicted the ER's label.
So, that leaves us with a huge question. If it wasn't a seizure and it wasn't a primary heart arrhythmia, what on earth caused James's system to crash so violently? To solve this, we kind of have to treat his body like a highly complex machine that just suffered a microscopic perfect storm. The clinical assessment breaks this whole thing down using what they call a 7-layer regulatory failure model. We are going to work backwards through this exact model to find the true culprit, and we'll see exactly how each biological layer breaking down compounded the failure of the next one.
To really understand the root cause here, we have to go all the way down to the cellular level. Layer 1. Specifically, we need to talk about ATP, or adenosine triphosphate. You can think of ATP as the body's primary energy currency. It is, quite literally, the essential electricity running your human power grid. Now, looking at James's history, he had a documented SARS-CoV-2 infection back in 2022, and this past viral infection acted as the root driver for everything that followed, because the virus essentially hijacked his cellular power plants, his mitochondria. Basically, James's body was simply running out of battery. In medical terms, this is a state of bioenergetic failure.
And this brilliantly illustrates exactly how that hijacking happens. If you look at the specific viral proteins listed, things like ORF9b, ORF9c, and the M protein, you can see how they directly target and mess with the mitochondrial machinery. They force the cell away from efficient energy production and basically shove it into a super low efficiency metabolic state. And what's absolutely crucial to understand here is that this creates a chronic, self-perpetuating injury cycle. Long after that initial virus is gone, the cellular power grid remains damaged, leading to severe ongoing ATP depletion.
Which naturally brings us to layer 2, autonomic dysregulation. Think of it like a city where the power grid is failing. What happens? The highest demand sectors start experiencing rolling blackouts first. The human body is exactly the same. Your autonomic nervous system, the background system controlling automatic stuff like your heart rate and blood pressure, requires massive, continuous amounts of ATP to keep running. Without enough ATP, James's autonomic ganglia, the key nerve hubs of this whole system, essentially glitched out. His nervous system literally could not afford the metabolic cost to respond to basic orthostatic or thermal challenges. So standing up or getting too hot in a shower suddenly became highly dangerous, simply because his body couldn't pump blood fast enough to compensate for the change.
Let's move to and see how this builds with layer 3. Take a look at his physiological parameters. His entire internal program was completely displaced. James had a deeply ingrained rigid sleep schedule. He was going to sleep around 4:30 in the morning and waking up at 1 in the afternoon. Because of his massive cellular energy crisis, his internal clock basically destabilized and anchored itself to this inverted schedule. This meant his morning cortisol surges, his blood pressure changes, and his core temperature drops were all occurring a full 8 hours behind environmental reality.
The assessment officially refers to this as the destabilization and pathological re-anchoring of the circadian phase. We are just talking about a bad habit of staying up late watching TV. This was a rigid biological phase shift. Because his body was waking up at a time when its internal clock firmly believed it should be resting, his brain perceived a massive, life-threatening energy deficit, and this resulted in a state of neurological insulin resistance. The outward symptom of this? It drove intense, practically uncontrollable cravings for sugar and root beer all throughout his day just to force some quick, cheap energy into a starving system. It's such a fascinating human detail, right? It really highlights just how desperately his brain was crying out for fuel.
That brings us to layer 4, which is represented by this highly specific number documented on his EEG, 7 Hz. This number represents his posterior dominant rhythm. Now for context, a normal, healthy, awake adult should have a rhythm humming along between 8 and 13 Hz. But James's rhythm? It had pathologically slowed all the way down to just 7 Hz.
But why did it slow down so much? Well, the ER assumed a structural problem, like a seizure focus in the brain. But actually, it was a neuronal energy failure, something called thalamocortical dysrhythmia. Remember that severe lack of ATP we talked about? Well, neurons are obligate, high-demand energy consumers. They are power-hungry. The 7 Hz slowing wasn't a structural brain lesion at all. It was literally a neuronal energy failure signal. The thalamus in his brain became hyperpolarized, essentially experiencing its own rolling blackout. The brain's internal timing was disrupted simply because it couldn't afford the metabolic cost of running at full speed.
And as you might guess, the chaos certainly doesn't stop there. This energy crisis spills over into layer 5, directly impacting mast cells, which are a key part of your immune system. Mast cells are also incredibly high energy demand cells. When they experience mitochondrial stress, they become primed. They're essentially placed on a total hair trigger. This drastically lowers the threshold for them to release histamine. So layer 5 acts as this massive system-wide amplifier. Every time these energy-starved mast cells are even slightly triggered, they just dump histamine into the body, which further destabilizes the blood vessels, making a fainting spell even more likely to happen.
So the crucial point is how all these compromised, weakened layers perfectly stack on top of each other. This brings us right to the climax on January 13th, adding in the final layers. Layer 6, his medication burden, and Layer 7, mechanical neck triggers. Think of this as the Swiss cheese model of system failure. Every single layer has a hole, and on this particular day, all the holes perfectly align to allow a catastrophic event to slip right through. Let's look exactly at how those dominoes fell. Okay, here is the exact physiologic stacking sequence of his second crash that day. Step 1. James wakes up at 1 p.m. on his inverted schedule, and he takes his prescribed beta blocker medication, propranolol. Step 2. That medication hits its absolute peak pharmacological effect 2 hours later, right at 3 p.m. Now, due to his shifted circadian rhythm we talked about, 3 p.m. is already his window of peak autonomic fragility. Step 3. During this super vulnerable window, he decides to take a hot shower. The heat from the water naturally causes his blood vessels to dilate. Step 4. He finishes the shower and he stands up. Gravity does its thing and causes venous blood pooling in his lower body. Normally, a healthy nervous system would instantly trigger a sympathetic surge to pump that blood straight back up to the brain. But his autonomic system is damaged, his mast cells are misfiring, and crucially, that propranolol he took pharmacologically blocks whatever tiny compensatory surge his body could even try to muster. The result? An unavoidable, catastrophic hemodynamic collapse, a total failure of blood pressure and flow, and he passes out. The assessment concludes by pulling back to look at the whole picture with this incredibly powerful summary. Stabilizing the terrain is the prerequisite for determining what, if anything, remains after the regulatory noise is removed. James didn't have epilepsy. He didn't have an isolated heart defect. He had a multi-system regulatory failure. Treating an isolated symptom, like, say, throwing heavy seizure medication at a fainting spell, is entirely useless and frankly even harmful if you don't understand the underlying biological terrain. You literally have to fix the cellular energy, correct the sleep clock, and remove the offending medications first before you can fix anything else.
It really is a striking reminder that the human body isn't just a collection of separate, isolated parts. It is a deeply, deeply intertwined ecosystem. Every medication you take, the exact time you go to sleep, the viruses you fought off years ago, they all interact in ways we are honestly only just beginning to map out. Which leaves us with a pretty fascinating thought to ponder. Next time you experience a minor glitch in your own health, how interconnected are your own biological layers? What invisible dominoes are falling beneath the surface right now? Thank you so much for joining me on this explainer. I really hope it gave you a whole new perspective on the absolute incredible machinery operating inside all of us.